Today, we will explore linear regression, focusing specifically on simple linear regression and its applications in predictive analysis. We'll also learn how to perform this analysis using Jamovi. Linear regression. A statistical method for examining the relationship between two or more variables and for making predictions, Montgomery, Peck, and Vining, 2021. This method is widely used for prediction and forecasting. Simple linear regression. Used to model the relationship between a single independent variable and a dependent variable by fitting a linear equation to the observed data. Pseudo case, enhancing academic achievement, the role of post-class video lecture review. Utopia National High School aimed to enhance student performance by examining final examination scores based on the number of hours spent reviewing recorded video lectures after regular classes. They investigated whether the time spent reviewing these lectures at home could improve academic outcomes. Data was collected from 25 randomly selected students, focusing on the total number of hours spent reviewing video lectures over the 4-week period and their corresponding final exam scores. Here are the possible research questions. To avoid redundancy, you may watch Group Frequency Distribution, Transforming Data in Jamovi for research questions 1 and 2. For this lecture, we will focus on research question number 3. Here are the hypotheses, and the significance level, or alpha, is 0.05 or 5%. Here is the dataset. Please open Jamovi and input this data. For the sake of illustrating simple linear regression, we will skip some assumption checks, such as normality, linearity, homoscedasticity, and others. However, in actual research, you should ensure that all assumptions are met. First step, go to Analyses Regression Linear Regression. Second step, select your dependent variable, the variable you want to predict. In this example, it is the final exam. And third step, select your independent variable, that is the predictor variable. In this example, the video review will be placed into the covariates box. Here is the generated result. The p-value for the video review predictor is 3.23 e-15, 3.23 times 10 to the power of negative 15, which is much smaller than the common significance level of 0.05. This indicates that the predictor is statistically significant. The t-value of 18.323 is also very high, further supporting the significance of the predictor. Here is the actual simulation using Jamovi. Given that the data is already encoded for the number of hours spent reviewing recorded video lectures and final examination scores, we will proceed directly to simple linear regression. The result generated is displayed in your screen. Let's understand the meaning of this. Let's start with the model fit measures. R, 0.967 or 96.7% indicates a very strong positive relationship between the number of hours spent reviewing video lectures and the final exam scores. R squared, 0.936 suggests that 93.6% of the variance in final exam scores can be explained by the number of hours spent reviewing video lectures. This high R squared value indicates that the model fits the data very well. F, 335.744. The F statistic tests the overall significance of the regression model. A high F value indicates that the model is statistically significant and that the independent variable reliably predicts the dependent variable. DF1, this represents the number of independent variables in the model. In this case, there is one independent variable, hours spent reviewing video lectures. DF2, is calculated by subtracting the number of parameters estimated, including the intercept, and the number of independent variables from the total number of observations. In this case, with 25 observations and one independent variable, df2 is calculated as 25 minus 1, the intercept, minus 1, the independent variable, equals 23. P-value. The p-value indicates the probability that the observed results could have occurred by random chance. The p-value here is 3.23 times 10 to the power of negative 15, which is much less than 0.05, suggests that the model is statistically significant, meaning the relationship between the independent and dependent variables is not due to random chance. Now let's understand the meaning of model coefficients. Intercept, 65.400. This is the expected final exam score when no hours are spent reviewing video lectures. It represents the baseline score. Video review, 0.812. For each additional hour spent reviewing video lectures, the final exam score is expected to increase by 0.812 points, holding all else constant. SE, standard error. This measures the accuracy of the intercept estimate. A smaller standard error indicates a more precise estimate. T-value, tests whether the intercept and the video review coefficients are significantly different from 0. A high t-value indicates that the intercept is significantly different from 0. P-value, both the intercept and the video review predictor have very small p-values, 6.79 times 10 to the power of negative 25 and 3.23 times 10 to the power of negative 15, respectively, indicating that they are statistically significant. Let's review our research questions. To reiterate, for this lecture, we will focus on research question number 3. The results, analyses, and interpretations for research questions 1 and 2 can be found in a separate video lecture titled Group Frequency Distribution: Transforming Data in Jamovi. This is the pattern we will use in the presentation of the results, analysis, and interpretation, table presentation, textual explanation, and discussion based on interviews and/or observations, supported by relevant literatures or studies. Here is the result of Table 3. Kindly read and understand the analysis and interpretation in succeeding slides. The analysis shows that the number of hours spent reviewing video lectures is a significant predictor of final exam scores. The model explains 93.6% of the variance in final exam scores, indicating a very good fit. Both the intercept and the predictor are statistically significant, suggesting that the baseline score and the effect of reviewing video lectures are reliably different from 0. Interviews and observations were conducted. Students reported that reviewing video lectures helped them understand complex topics better and allowed them to revisit challenging sections multiple times. Observations indicated that students who spent more time reviewing video lectures were more engaged during class discussions and performed better in practice exams. Research supports these findings. Studies have shown that the use of lecture videos can significantly improve student outcomes. For example, K. 2012 found that students who had access to lecture videos performed better on assessments and reported higher levels of understanding and retention. Another study by Austin, Lupcheniuk, and Weidman, 2011, highlighted that lecture attendance and the use of recordings predicted final exam performance, reinforcing the importance of video lectures as a learning tool. These insights and supporting literature align with the regression results, reinforcing the conclusion that the number of hours spent reviewing video lectures positively impacts final exam scores. Thank you. I really hope you learned from this lecture.